Assalamu alaikum and good morning. I am Nurhanima R. Abdussamad. I'm going to discuss the solutions on our previous forecasting quiz. So let's proceed to the problem. Sales of Coolman air conditioners have grown steadily during the past 5 years. The sales managers had predicted before the business started that year one's sale would be 410 air conditioners. So, using exponential smoothing with a weight of alpha 0.30, develop forecast for years 2 through 6. So, here is the table on the left side stating the sales during the 5 years of operations. So the year one's sale 450, 495 on the second year, and so on and so forth. Let's proceed to the answer or solution for the problem. Using exponential smoothing with a weight of alpha 0.3, develop forecast for years 2 through 6. The first year's sales forecast is given in the problem, which is 410. So we will be computing the second year forecast up to the sixth year forecast. So the 410, which is the forecast last period, add the alpha 0.3 multiplied by the difference between the sales last period, which is 450, less the forecast last period, which is 410 given in the problem. So we will get a total of 422 units. Next, third year. So 422, which is the forecast that we computed, and then add the 0.3 alpha multiplied by the difference between the sales last period, which is 495, less the 422, the sales forecast for the second year or the last year. So we will get a 443.9. We just have to follow the given formula in the exponential smoothing, which is to compute for the forecast in the current period. So you will add the forecast last period and the alpha or the weight or the smoothing constant, which is also given in the problem, and then multiply by the sales last period, difference between the sales last period and the forecast last period to get the forecast this period. So how'd you get the sixth year forecast? So 495.2, which is the forecast last period, add the 0.3 alpha multiply by the difference between the sales last period 584 less 495.2, we would get a 521.84 units. That is the sixth year forecast. The second requirement, using smoothing constants of zero point 0.6 and zero point 0.9, develop forecast for the sales of Coolman air conditioners. So here is the table showing the computations of the forecast using the alpha 0.6 and alpha 0.9. So we just have to simply follow the given formula in the exponential smoothing, which is also applied in the first requirement in this problem, that the first year's forecast 410 at the zero point 0.6 alpha multiplied by the difference between the sales in the last period 450 less the 410 forecast last period. So we will get a total of 434, so on and so forth, and which is also applicable to the next forecast using the alpha 0.9. So we just have to simply use the formula. So let's jump to the sixth year using the alpha 0.9. So we will get the sixth year forecast by computing the forecast last period, which is 558.2, add the 0.9 alpha multiplied by the difference between the sales last period, which is 584, less the forecast last period. We will get the total of 581.4. So simply use the formula to compute. It is very easy to compute. The third question is, what effect did the smoothing constant have on the forecast for Coolman air conditioners, and also which smoothing constant gives the most accurate forecast? So here is the table showing the computation of the absolute deviation of each forecast using different alphas. So as you can see on the third, fifth, and seventh column, we just have to lay down the figures that we have computed in the previous two question or requirements. So we just have to lay down or input the figures of the forecast using alpha zero point 0.3, forecast in the fifth column, forecast alpha using 0.6, and also forecast using alpha zero point 0.9. So how do we get the absolute deviation for the fourth column? So how do we get each of these absolute deviation? Simply deducting the sales by its forecast using alpha zero point 0.3, 450 less 410, that will give us 40, 495 less 422, it will give us 73. So on and so forth. Then add the absolute deviations that we have computed in order to get the total absolute deviation 372.77. That is the absolute deviation using the alpha zero point 0.3. The sixth column, how do you get the absolute deviation for each year? So simply by deducting the sales to each forecast using alpha zero point 0.6. So 450 less 410, it will give us 40, 495 less 434, 61, 518 less 470.6, it will 47.4, 563 less 499, it would give us 64, and so on and so forth. And then add each of the absolute deviation, add them all, and it will give us the total absolute deviation of 259. Same with the last column, which is also to deduct the sales forecast using the alpha zero point 0.9. So 495 less 446, it is 49. 518 less 490.1 equals to 27.9. So add these figures in the last column, it would give us a total absolute deviation of 190.5. So we can get the mean absolute deviation as shown in the second table. The mean absolute deviation using alpha zero point 0.3 is 372.77 divided by 5, since we have 5 figures in the absolute deviation column, equals 74.55. And then the mean absolute deviation using alpha zero point 0.6, 259 divided by 5, that equals 51.8, and mean absolute deviation using alpha zero point 0.9, 190.5 divided by 5, 38.1. So the most accurate forecast is the 38.1, or the forecast using alpha zero point 0.9. So as we all know, mean absolute deviation is a measure of forecasting errors. Therefore, the lower it is, the better. The best of this is the exponential smoothing with the lowest mean absolute deviation of 38.1, since it gives us the lowest result. So it is the most accurate forecast. Fourth requirement, use a 3-year moving average forecasting model to forecast the sales of Coolman air conditioners. So here is the table. On the third column, we can see the computation of the 3-year moving average using the previous 3 years sales, which 584 plus 563 plus 518 divided by 3, since we have used the 3-year moving average, so divided by 3 equals 555 units. So the 6th year forecast is 555 units. Using the trend projection method, develop a forecasting model for the sales of Coolman air conditioners. So here is the first table showing the computation of the summation of x and the summation of y, the summation of x squared, and the summation of x and y. So as we can see that our n is odd number 5. So in the middle year, we will going to assign 0 to it. then assign the upward values in increment of -1, and then the downward with +1. So the third year is 0, the second year is -1, and then the first year is -2, and then the fourth year +1, the fifth year +2. That would give us the summation of x is equals to 0. On the third column, y, that is the sales which is given in the problem. In the first year 450, second year 495, 518, 563, and 584 on the fifth year. So the summation of y is equals to 2610. And then on the fourth column, which is the x squared, is to simply square the x on the second column. So -2 squared, +4, -1 squared, +1, 0, 1, and 2 squared equals to 4. So the summation of x squared is equals to 10. And then the last column, which is the x and y, is to multiply the second column to the third column, which is the x and y. So -2 multiplied by 450, that would give us -900, -1 multiplied by 495, -495, so on and so forth. So the summation of x and y is 336. So as you can see on the left side of this slide is the small box which contains the computation of x and y. Summation of x is equals to 0 divided by the n, or the 5, and then we could get the value of x as 0. And then also summation of y, 2610, divided by n, which is 5, that will give us the value of y, 522. So on the next table, we can see the computation of the slope b and the y-intercept to get the trend equation for the problem. So slope b, summation of x and y less the n multiplied by x and multiplied by 1 over the summation of x squared minus n multiplied by x squared, which is we have computed it already. So 336, which is the summation of x and y. As you can see on the upper right side of this slide, that the table showed that the value of x is equals to 0. So therefore the whole term coming after the summation of x and y becomes 0, and also coming after the summation of x squared in the denominator, the whole term becomes 0. So we can get the summation of x and y, 336, divided by the summation of x squared, 10. So 336 divided by 10 is equals to 33.6. And the y-intercept, y minus b, x. The y-intercept, or a, y minus bx, is simply the value of y, since the x is equals to 0. Therefore, the whole terms become 0. So the y-intercept is equals to 522. With that computation of the slope b and the y-intercept, we can form the trend equation y is equals to a plus bx. So y is equals to 522 plus 33.6 times x. Basically, we can compute the 6-year forecast by substituting the x with 6, since we are computing for the 6th year. So y sub 6 is equals to 522 plus 33.6 multiplied by 6. So we can have the 6th year forecast 723.6. Last question. Would you use exponential smoothing with a smoothing constant of 0.3, a 3-year moving average, or a trend to predict the sales of Coolman air conditioners? So using the smoothing constant 0.3, we can get the 521.84 units, and then using the 3-year moving average, we can get 555 units. Using trend projection, so we have computed that we can get the 6th year forecast 723.6 units. To answer the last question, I would prefer to use the 3-year moving average since it gave me an accurate units of the 6th year forecast, and also it is very easy to compute since you just have to use the previous sales data to compute for the forecast and divided to the corresponding number of years used to get the forecasted units. That could be all. Thank you for listening and hoping that you have learned something from my discussion in our previous forecasting quiz, and Assalamualaikum.